So the study obviously involved the 31 farms, all hosting Friesian herds, 18 of which were pedigree registered. And the average herd size on the farms was 195 cows, and there was an average annual milk yield per cow of 8,800 litres, with an annual concentrate feed level per cow of 2.9 tonnes. And Gregory visited about 5 to 7 times between September 18 and 19. And on each visit, he collected data and feed samples. So what we did with all this data that we collected, we split it into 2 time periods. So first of all, we concentrated on the winter period. This is when cows were housed full time. And we used the data from months 2 to 5 post-calving. We did exclude the first month because a lot of cows were still on build-up strategies and weren't on a true feed yield. We also had a look at the grazing data on 18 farms that grazed cows full-time over May, June and July. We'll not present much of the grazing data tonight. The main study is on the winter feeding period. However, in the farmer's booklet, there will be a little bit more on the grazing data. So looking at then this build-up period, so as you can see along the bottom of the graph here is the number of days until a true feed to yield commenced. So as you can see, there was 4 farms who had started feed to yield before day 20, and the majority of farms had adopted a feed to yield approach by day 30. There were 3 farms that delayed feed to yield until at least day 60 post-calving. A very similar graph then looking at the feed rates adopted. So along the bottom we have the amount of concentrate fed per kilogram of milk, and the numbers up the left then is the number of farms. So as you can see, the majority of farms, 20 farms, adopted a feed rate of 0.45 kilograms of concentrate per kilo of milk that was produced. And a small number adopted higher and lower feed rates, but we didn't have enough variation in the feed rates within this study to really examine the effect of feed rate on cow performance. Another thing that Gregory did while I was out on farm was calibrate some feeders. So there was feeders calibrated on 17 farms. And this graph shows the average deviation from target. So 0 was the target. We didn't want any deviation. So if the feeder was to drop 1 kilos, and it did drop 1 kilos, that would be 0 deviation. So each bar here represents a farm. So as you can see on farm 1 and 2, the average deviation was they were underfeeding by more than 10%. Whereas on the other end of the scale, farm 16 and 17 were actually overfeeding by more than 10% on that. And the main message from this is that the regular feeder calibration really is critical to ensure that your precision feeding isn't actually being let down by the feeders. Now, for each cow and for each month, we predicted intakes using equations that have been developed at AFBI for housed feed to yield cows. So bear with me because there's quite a lot in this graph. So along the bottom here, we have the concentrate intake per day, and then up the left, we have the dry matter intake in kilos per day. So as you can see, as concentrate intake increased, we also found that total dry matter intake increased, and this would be expected. However, we do see that forage intake is very constant across all those concentrate intakes. Part of the reason for this is that only cows that are producing high volumes of milk are being offered the higher concentrate intake or the higher concentrate levels. So these cows, they probably have the higher intake capacity to be able to consume that concentrate without it impacting on their forage intake. This finding also supports the assumption that there's a single M+ maintenance plus value for one for cows and one for heifers across the whole herd. So the one thing though is as concentrate intake of 18 kilos per day, we find then that the concentrate proportion of the diet reaches 58%. And this does mean that those cows will be at increased risk of rumen problems. Now, most farms didn't feed their highest yielding cows any more than that sort of 15 to 18 kilos of concentrate per cow per day. However, there were 2 farms that did feed up to 22 kilos of concentrate per day to their highest yielding cows. So the previous graph was looking at all the data from the farms together. This is then taking some individual farms to look at what that is like on farm. So the blue values are representing heifers and the red values are representing the cows. So as you can see on most farms, there's this very clear trend, whereas the concentrate dry matter intake across the bottom, we see that the total dry matter intake increases, whereas the forage dry matter intake remains reasonably stable. Now, looking at this example here, we have a farm where we almost see the forage dry matter intake decreasing. Now, this farm 3, it has very, very high concentrate intakes. So we can see that at these high concentrate intakes between 19 and 23 kilos, that it is starting to depress the forage dry matter intake. But on most farms, we see very similar curves. Moving on then to milk yield. Usually the milk response is curvilinear, but this is a feed to yield study. And again, we're seeing this linear response because the concentrate is being fed according to the milk yield. Now, what we did find is that part of this increase in milk yield was actually due to genetics. So cows that were being fed greater concentrates had greater milk yields because of their genetic potential. However, most of the variation was due to forage quality and general management. Again, looking at some examples from individual farms, we see that there's the linear response. So you have the concentrate dry matter intake along the bottom, and then up the left, we have milk yield. And again, very similar linear responses. Moving on to milk fat and milk protein. In this graph, we have the concentrate intake again along the bottom and the percentages of the fat and protein up the left-hand side. So as you can see, as concentrate intake increased, milk fat decreased. However, there was no change in the milk protein, but it was not affected. Now, from the farms that we had genetic data for, we found that approximately 50% of this reduction in milk fat accounted for by the genetics, but the other 50% then was due to diet, mainly the high starch and low fiber as the drivers to this. However, interestingly, on a couple of farms, there actually was no reduction in milk fat across the concentrate intake levels. And this is due to the constant genetics in that farm across the concentrate range. And also those farms also tended to feed alternative forages. That is, concentrate dry matter intake increased, then the fat percentage decreased. And again, the blue dots are heifers and the red dots are cows. So example 1 and 2 are very typical, whereas in example 3 and example 4, we see that there's no decrease in milk fat on these farms. Even at the higher concentrate intake levels, that there's still that variation in milk fat, similar to the lower concentrate intake levels. Looking then at some milk proteins in individual farms, again, blue dots are heifers and the red dots are cows. And we have the concentrate intake along the bottom and the milk protein up the left-hand side. And in most farms, example 3 and example 4 would be like most farms where there really is no change at all in milk protein. However, in example 1 and 2, we can see a slight decrease in milk protein. Now, although the main results of this study or in this presentation are for the winter period, I just wanted to throw up one slide from the grazing results just to show the change in milk composition when grazing. So milk fat, when grazing, there was a reduction again as concentrate intake increased, milk fat decreased. And this decrease was even higher during the grazed period than the housed period. And surprisingly, we also seen the milk protein decrease as concentrate intake increased. Now, because these results were only taken from the very early grazing season, they probably don't paint a whole picture, but it's still interesting nonetheless that the same pattern is seen in grazing as to the housed cows. We also wanted to look at some efficiency measures. So a very common efficiency measure used on farm is how many kilos of concentrate is being offered per kilogram of milk that is being produced. So again, we have the concentrate intake across the bottom and the amount of concentrate offered per kilogram of milk that's actually produced up the side. So as you can see, as concentrate intake increased, then we start to see that the concentrate offered per kilogram of milk also increases. And this means that there's actually lower concentrate use efficiency because we have moved then to more concentrates, which is also more expensive diet to feed. We looked at some of the fertility parameters of these cows. We split the cows into either low concentrate group or high concentrate group. So the low concentrate group, an average of 10 kilos of concentrate per day, whereas the high concentrate intake group had an average of 15 kilos of concentrate per day. But we see no effect of concentrate intake on any of these parameters, pregnancy to first service, the number pregnant at 100 days post-calving, days to confirmed in-calve, and the conception rate. So no effect of concentrate on any of those fertility parameters. Looking then at the economics, so what is each kilogram of milk worth whenever we apply a very standard bonus, milk bonus or deduction? So this first graph here shows the heifers, and we've split them into 2 kilo concentrate bands. So this is the concentrate intake across the bottom and the amount of bonus or deduction kilogram of milk. So as you can see, the heifers that are offered for 6 kilos of concentrate had an average bonus of 2 pence per kilo of milk. However, as concentrate intake increased, this bonus was reduced. It's even more obvious in the cows, where as the concentrate intake increased, then we actually start to get a deduction at 16 to 18 kilos of concentrate intake per day. So there's a loss of about 2 to 2.5 pence per kilo of milk, and this is due to the poorer composition at these very high concentrate levels. Taking that further then into margin over feed costs. So when we talk about margin over feed, that is the value of the milk less the feed, the forage and the concentrate that has been used to produce that milk. So we use very standard for the winter period. Concentrate cost at £260 per tonne, and we find very similar trends. And we looked at 3 different milk prices, 18, 26 and 34 pence per kilo of milk. So we're looking first at 34 pence per kilo of milk. So as you can see, as concentrate intake band across the bottom increased, so did the margin over feed costs. So it did make economic sense to continue feeding the highest yielding cows in the herd those high levels of concentrates. But of course, these cows that are eating 16 to 18 kilos of concentrate a day are very close to a metabolic tipping point. And so the ration really must be very carefully formulated. Going forward, we also need to think of the environmental challenges about meeting the phosphorus balance and also sustainability, as there's more scrutiny on the use of human edible feeds in farm animals. But what happens when milk price then is reduced to 26 pence per kilos? Well, overall margin is substantially reduced, as you would expect. Again, we can see as concentrate intake increases, the margin does increase. However, when we get to 14 kilos of concentrate intake, the increase is very, very small. And yet you're still getting those metabolic risks, these higher yielding cows being fed high levels of concentrate, but we're not seeing an economic response. But what if the worst happens and milk goes down to 18 pence per kilo? Well, obviously the margins are extremely low. And we can see as well, there's very little increase in the margin over feed costs. In fact, it starts to decrease after you get past that 14 kilos of concentrate. So at very low milk prices, chasing these extra litres at these very high concentrate intakes will deliver very little in terms of your margin over feed cost. So why, as concentrate intake increased, did we not continue to see an economic response? Well, this is partly due to the decreasing value of each kilogram of milk. So we've seen in the bonuses slide that the bonus is reduced and could even become a deduction. And while that's happening, we also get an increased cost of the diet, because those cows are eating a diet that is now a greater proportion of concentrate, which is your most expensive feed. Again, just to pick 2 cows to try and look at what this looks like on an individual cow level. So we have selected a farm here with 2 cows. So we have a black star and a red star. And this is just a little profile of those cows. So we see that the black star cow, she is being offered about 13 kilos of concentrate per day. Her milk yield is 42 kilos, and she has a fat percentage of 4.48 and a protein percentage of 3.3. Now compare this then to her herd mate in the red star, who has been offered 17 kilos of concentrate and she's producing 10 litres more milk. She's producing 52 litres of milk. But her fat has reduced a little bit to 3.47%, and her protein has reduced to 2.85%. So what does this look like in terms of their bonuses? Well, Black Star cow, she has a bonus of 1.82 pence per kilo of milk, whereas the Red Star cow, she's actually losing 2 pence per kilo, or is being deducted 2 pence per litre. Now, to feed the Black Star cow, she only costs £5.78 to feed a day, because she's not eating as much concentrate as her red herd mate, who's eating £7 per day. So again, what does this look like at each of these milk prices? So we can see that a milk price of 34 pence per litre, they have very similar margin over feed costs. In fact, the Red Star is even slightly better. So it makes sense to feed these two cows. However, when milk price then is reduced to 26 pence per litre, we can see now that the cow with the Red Star, her margin over feed costs are now 50 pence less than the cow with the Black Star. And again, as milk price decreases again, you can see now there is £1.30 difference between them. So the cow that has the lower milk yield is producing slightly less milk, but a better composition, is actually more economical than the cow that is eating the higher concentrates and has the higher milk yield, but has the lower milk composition. So as in conclusion from this study, we find that as concentrate feed level increased, it did increase the total dry matter intake into the cow without reducing forage intake. We found a linear increase in milk yield, but we did find that milk fat decreased on most farms, and this is due to genetics, but also to diet. Milk protein, however, was not really affected by concentrate level, and we found no effect on cow fertility. We did find, however, that as concentrate intake increased, that milk bonuses were reduced. Now, the economics are very much determined by the milk price versus the concentrate cost. So at a good milk price, feeding those higher yielding cows, the high levels of concentrates may make economic sense. But again, bear in mind the metabolic stresses that puts on the cow, and also the environmental and sustainability challenges. At a moderate milk price, there was limited economic benefits of feeding those higher yielding cows more than 14 kilos of concentrates. And at a low milk price, really feeding more than the 12 kilos of concentrate, there was very limited economic benefit. So at these low milk prices, it's not good economic sense to chase the extra litres by feeding extra concentrates. Some practical issues, some take-home messages: calibrate your feeders often. Also check the accuracy of milk meters, so we know that you know what your cows are producing, and check the settings on your parlour software as well, your feed rates, and maybe have a discussion with your advisor about what feed rate may be appropriate for the milk compositions on your farm. Also, be aware of the level of performance that your basal ration is supporting, and again, check the milk composition of your highest yielding cows. Are those high feed levels reducing their milk composition? And of course, for the higher yielding cows, watch out for signs of subacute acidosis. And again, keep focused on milk composition when you're selecting your sires.